All right, class, welcome to the first video. We're just going to go over 0-2, 0-3, 0-4, 0-5 real quick. Make sure you take pretty good notes. Honestly, if you want to try and screen capture this and print it off, you might want to do that, but I would suggest writing them down yourself. First of all, here in 0-2, we're talking about numbers. And the only thing I want you to know here is the difference between natural numbers, whole numbers, and integers. If I can ask you to count to 10, naturally you're going to start at 1. So that's how you can remember natural numbers. Whole numbers have the 0, and integers go through the negatives. Rational numbers can also be a fraction, a over b, as long as b does not equal 0. Irrational numbers, numbers that cannot be defined as a repeating decimal, like in this case, 0.03, 03, 03, 03, or it could be 0.03 with a repeat sign over it, which would look like 0.03, like that. Or if you cannot put it in a fraction form where b equals 0, for example, pi cannot be defined in either way as a repeating decimal or as a fraction. That's really all I want you to know from that one. All right, on this one, we're using these integers that we just learned about to do different operations. The easiest thing to do is to make a number line to count on. In this case, we're using a number line to find -3 plus -4. So we start here at -3, and we need to add -4, which in our case we're going backwards for. 1, 2, 3, 4. -3 plus -4 gets us -7. You can also use absolute value to add integers. I don't know if you guys have heard of the little poem that they made. Same signs, add and keep, different signs, subtract, keep the sign of the larger one, and you will be exact. For example, we scroll down here. Here on the left side, right here in green, the signs are the same. Add the numbers together, keep the sign. Add 3 and 5, keep the negative, or add 3 and 5, keep the positive. Over here in blue, no, that's green still. There we go. Blue, different signs, subtract the numbers, and keep the sign of the larger number. So 3 plus -5, subtract them. 5 minus 3 is 2. The 5 has the larger number, and it's got the negative sign. We'll keep the negative. Down here, 5 minus 3 is 2. 5, the larger number, has a positive, so we'll keep positive. So if we're doing an example, and we have -11 plus -7, what we just learned, as you can see with the -3, -5, same signs, add and keep. So we're going to 11 plus 7 equals 18. Add and keep the negative, so it's -18. That's not a good. Let me try and erase that. Do this way. Keep the sign, add them together, -18. All right, if you're multiplying integers, same sign, the product's going to be positive. Different sign, the product will be negative. So we have +4, -5. We know the product's going to be negative. All we have to do is multiply 4 times 5, and we'll get -20. Down here, it's the same sign. We have a double negative, so we're going to know the product is positive. 51 divided by 3, I believe is 17. I couldn't remember if it was 17 or 13. And we're dividing a negative. Let's see, I should work this one out.
They cancel out.
They do cancel out.
Because they have the same signs.
Same sign, product is positive. So just remember that.
An example of one with 3 names.
3 negative signs.
Yeah, like -2
We have 3 negative signs. Negative
times
2
-3
times negative 3
times -4.
times negative 4. If we have, what we're really going to do
Count the
is,
minus signs. If it's an odd number, it's negative.
yeah, if it's an odd number of minus signs, it's negative. Or if you want to break it down and do piece at a time, -3 times -4, you get positive 12. And then take the 12 times -2, -24. Either way you want to do it will be fine. 0-4, we're talking about fractions here. Really, they just want you to find the least common denominator. So if we have 2/3 plus 5/6, first thing we want to ask is 3 a factor of 6, or does 3 go into 6 evenly? The answer is yes. So all we got to do is know that 3 times 2 equals 6. So we're going to multiply the numerator and denominator by 2. So it looks like this. If you ever see something like this, you have to know that any fraction over the same number will always equal 1. And you can multiply anything you want by 1, and even though it changes the numbers, the value of the number does not change. So now we have 2 times 2 equals 4, 3 times 2 is 6. So instead of 2/3, it'll read 4/6 plus 5/6. Add the numerators, keep the denominator, and then you get 9/6 or 1 1/2. Make sure you simplify as much as you can. When one denominator is not a factor of the other, for example, 1/2 plus 2/3, just multiply the fraction with the opposite denominator. So we take here, we have 1/2 multiplied by the denominator 3 over 3. And then the 2/3, we multiply it by the 2 in the denominator on the other side, 2/2. Because we can multiply anything we want by what we put up here. And it's not going to change the value of our number. Add the numerators, keep the denominator. Answer will be 7/6 or 1 1/6. Make sure you always simplify. You could also use a number line, an absolute value, to add and subtract fractions. It's the same thing as in 0-3 with the number line. You're just using fractions instead of whole numbers. On 0-5, we're multiplying fractions now. Just remember, if it's different signs, it'll be a negative product. Same signs, positive product. It's the same thing as if they weren't fractions, they were just whole numbers. So for example, 2/5 times 1/3, all you gotta do, multiply the numerators, multiply the denominators, and simplify. So you take 2 times 1 here, and 5 times 3 here. And then your answer becomes 2/15. It's pretty much that simple. If you have two numbers whose product equals 1, they are called reciprocals, and you'll hear that a lot. So for example, 3/8 times 8/3. We'll have 3 times 8, 24, 8 times 3, 24, 24/24 equals 1. And that's the same thing as we were talking about in the other one. Lastly, when we're dividing fractions, you multiply the dividend, which is x, so whether it looks like this, whether it looks like this, or whether it looks like this, x is your dividend, by the reciprocal, and if you remember reciprocal, it's just basically the flipped fraction of the divisor, which is y. So when you have x as a fraction and y as a fraction, it might be written out like this: 1/3 divided by 1/2. All we're going to do is flip the 1/2 to make it 2/1 and multiply them together. 1 times 2 is 2, 3 times 1 is 3. And when dealing with negative numbers, I find it's easiest to keep the negative sign with the numerator. That way you don't double negative or anything like that to where it's a wrong answer. But that is pretty much it for this section.